Welcome to the second Prisma Meetup. This is our last edition for the year, and today we have three different presentations. At first, we will have Josh Berkus, who's a Kubernetes community manager at Red Hat and a longtime contributor to the Postgres project. He'll be giving a great talk about query planner visualization for Postgres. This will be followed by a presentation by our very own Alberto, Perdomo, and Tom Houle, who are working on Prisma Migrate. As you might know, yesterday we had a big preview release of Prisma Migrate, and today they will give us an update on some of the most anticipated feature in Prisma, and that is Prisma Migrate, that has been in experimental state and has now reached preview state. Finally, we will have our third speaker, Dillon Raphael, who will present a marketplace app that is built using Blitz.js and Prisma, and he will showcase how easy it is to work with relations in Prisma, especially when using forms. So now, without any further delay, I'd like to bring Josh Berkus to the stage. Josh.
Hello. Yep. Hello, everyone. Let me go ahead and share my screen so we can see slides.
It's nice to see you.
Okay, slides coming through?
Not yet. Let's see.
Wait, what happened there? Try that again.
Oh, there we go. I'm gonna. Okay, so
there we go.
The stage. All the best, Josh.
Okay, so welcome everybody. I'm going to talk a little bit about query troubleshooting. Now, all of the examples and the details I give you are going to be about Postgres, but both MySQL and SQLite also have explain. They work along the same principles, although of course the details and actual code terms are a little bit different. So, what's explain? Why should you care even? Well, so if you're running an application in production, you have eventually run up against the application being unresponsive because of being out of resources or taking far too long to fulfill requests. And when you're not fulfilling requests, you start out with your sort of timeout troubleshooting, right? So you figure out which of your requests are being slow. You trace those requests. And sometimes it's your code, or something else that's causing the request to be slow. But sometimes you find out what you are waiting on is a database call, right? And you figure out which database call you are waiting on. And then what? So the next step there is you need to figure out what the query is that Prisma is generating for that database call, right? Because you've already traced your code, and so now it's time to trace the database's code. And the database's code starts with an SQL query. You can do that inside Prisma by going ahead and logging queries through Prisma, possibly through that individual call, which would be recommended rather than generating a ton of output. Alternately, if you are doing a performance audit of your entire application, you can set up Postgres. I know you can do this in MySQL. I'm not sure whether or not you can do this in SQLite, but you can set up your database to log all queries or to log all slow queries, which is actually the combination that I'm showing here for Postgres in the Postgres settings, so that you can actually see what's running and do a performance audit of the whole application. Either way, you end up with a query. So now you have a query. You know which query or set of queries is slow. So what's next? Well, what's next is explain. So what the explain command does is it shows you what the query planner chose to do, how it chose to fulfill your request, gives you stats on how the query actually was executed, implies some reasons why the query was slow, does tell you which individual step in the query took the most time. What it's not going to do is if a particular step in the query is really slow, tell you exactly why that is broken. There'll be hints, particularly if you use some external tooling to help you gain insight from this. It also, one of the most important things is there are other reasons for a database call to be slow other than query execution, such as round trip time between the database server and the application pods or servers, and other things. So you always need to potentially anticipate those. But explain is our next step in tracing why our database requests are slow. So the rest of this talk, I'm going to actually go into exactly some of the basics on how to read and explain so you can gain insight into why your individual database requests are slow. So, but in order to explain what explain does, I have to actually give you some background on what the query planner is and how it works. Because what you are reading and explain is the query planner's own output. So how a query planner works, and again, this is true across SQL databases that I know, is it breaks the query down into bits of work called nodes, as in retrieve this bunch of rows from this table, then correlate the bunch of rows with some from another table. So it breaks it down into nodes. It figures out every possible way to execute each node, and the approximate amount of work that they'll take, chains that together into what's called a query plan, and then figure out what the cheapest query plan is. The Postgres query planner was originally written in Lisp. I think it still shows, even though it's no longer in Lisp, in how it's organized. So now in Postgres, the individual nodes all have the same sort of format, right? Which is for each node, you have a set of rows going into the node from the database, a set of parameters that were supplied by your query, either directly or by implication, and then you will have a row set coming out of it. So for example, if you're on a sort node, which does what it says on the tin, what you're going to have coming in here is the rows from retrieving data from a table, the sort columns that you have given the query, and the output will be sorted rows. So to look at that in code here, so we're now doing tracing via the explain command. This is what a sort node would look like, right? And so this is saying, hey, we've got 808 rows that we are sorting. Here is the sort key that we're sorting on this. Here is the, and then some detail about how the sort was implemented, that Postgres decided to do a quick sort. It needed 43 kilobytes of memory, etc. So this is the individual node for just a sort step in a larger query. Now, what I'm showing you here is the text mode that comes directly on the PSQL console when you are doing explain. This is what I'm going to show you through the rest of the presentation. I actually do not recommend that you use this. Instead, I recommend that you use one or more of the helper tools that give you a more graphical explain. The reason why I'm using the text mode in this presentation is simply that the helper tools do not make for good slides, largely because I can't enlarge the text, whereas I can do that in text mode. One of the helper tools that I've used for a long time, a guy named Hubert in Poland maintains this website called explain.depsys.com. And you get your text mode explain plan out of Postgres, you paste it in there, and it actually breaks it down into steps, and plus gives you some hints as to what the query planner is doing, including what it is doing wrong. There is a second web tool called PEV that does this now in a more modern format where you can actually see the query as a tree structure. And see it that way and drill down. And if we actually were to click down through some of these, you could actually see more details about what it was doing in that step. These graphical formats are actually going to help you a lot. You'll notice that it's giving you hints as to which individual nodes are executing badly. These are going to help you a lot. I strongly recommend that you use them, even though you're going to see text mode in the rest of this presentation, just because I need it for slides. So One of the things that we talk about here a lot is cost. The important thing to know is you're going to see these cost numbers. These cost numbers are arbitrary. They're only meaningful in comparison to each other. A lot of people try to translate them into, say, milliseconds of execution, which generally does not work out. They're not meant to be that. People play with some of Postgres' parameters to try to get them to line up to milliseconds of execution, but that's always only approximate. Costs are only comparable to other costs. They're not comparable to any real world figure. Again, so here's an example of a very simple query. So we are querying one table, looking up a library patron based on their library card number. And it's going to go straight for an index scan, which makes sense. And this is giving us, hey, we're doing the index scan. It has this low cost. And this is the index condition that it is looking in the index for here. And again, there's that cost, but that cost is only comparable to itself. And it's a very low number. I've been telling you, slow queries tend to have costs in the tens of thousands or the millions. Single digit costs generally relate to queries that Postgres at least thinks are going to be extremely fast. So one of the other differentiations, and this is a specific Postgres thing, I don't think it applies to MySQL or SQLite, which is explain versus explain analyze. So explain says, query planner, tell me how you plan to execute this query and what the parameters are, right? Explain analyze says, tell me how you plan to execute this query, execute the query, and then come back and tell me how you did. Important note here, if you are analyzing a query that changes data, like an update or insert or delete query, it will actually update, insert, or delete. So if you are just testing the query for speed, you might want to do it in a transaction so that you can roll it back afterwards. You can see here the difference is we're doing now an explain analyze, right, of that same query. And so we've got the plan here of doing the index scan and the index condition. And then we actually have some data about the node, right? It took 0.1 milliseconds for the planner to plan the node, and it took 0.07 milliseconds to actually execute that and retrieve the patron record, which happened to be in memory because it's a small database. So there we're getting our actual execution information. You can get a lot more execution information with analyze and a bunch of parameters. Now, this means that most of the time that you're doing this, you want to use explain analyze, because that will actually tell you a lot more about where the query went wrong and why it was slow. The only reason why you wouldn't use analyze is either the query takes literally forever, you're just checking whether or not the new index you created is going to be used, or if you have a partition table, you're checking whether or not it's Postgres is correctly making use of the partitioning to only access one partition instead of the entire giant data warehousing table. So most of the time, you're going to want to use explain analyze in Postgres. There's a bunch of other explain options, buffers to show memory usage, costs and timing to show a bunch more detail. You can do different formats. You can get a lot of additional detail. You can play around with these. Buffers, for example, shows you memory usage from Postgres' perspective, which might be different from the OS's perspective. You can do it in different formats to make it more readable or more machine digestible. If you're using the PEV graphical tool, for example, it wants you to do JSON format as its input. Verbose gives you a lot more information about what's being queried. Actually, verbose is really useful for detecting one common problem, which is if you have a very wide table, like a table with 45 columns, and you actually only need one of those columns, if the query is being generated badly by the ORM, you might actually be retrieving all 45 columns when you don't need all 45. And that causes the query to require a lot more memory than it would otherwise. So let's talk about how you actually read this output, right? Because I've shown you a bunch of examples. Let me explain what they actually mean here. So the first thing to understand about Postgres Explain is that it's what we call an inverted tree, as in the stuff that's executed first is at the bottom and the stuff that's executed last is at the top. And it's also indented that way. So for example, this is the first step in this query. It does a bitmap index scan on the lone partition table. Next, it actually simultaneously does two different steps. We're joining two tables, and so Postgres will actually take advantage of I/O waits in order to scan two other tables simultaneously. And then on the third thing, it will actually do the join of those two tables. And so that's the sort of ordering of it. And even if you use the graphical tools still have stuff in inverted trees. And so you need to understand that, because otherwise you might look at the top and assume the thing at the top is what's being executed first, whereas it's what's being executed last. So let's look at one line of explain here and explain what you're seeing here. And again, in the graphical tools, you're going to have the same details, just in a different format. So the first thing it'll tell you is what operation it's doing, an index scan. So we're looking up something in an index. And the second thing it'll tell you is the approximate cost with details, right? So what's the planning execution cost expected for this? How many rows do I expect to retrieve? And how wide in bytes are those rows? So one of the things that you'll notice is these costs cascade upwards and they overlap. So in some cases, the second step of execution doesn't begin until the first step is completed. So like right here, we see we're ending on a cost of 151 and we're starting on a cost of 151. So this step doesn't start until this step is completed. But this step apparently can start while this step is still in process. And so it tells you a lot about sort of parallel execution that way. And same thing with sort of a final step. And you can actually kind of understand this, right? Where if Postgres is waiting for rows from disk and it's getting them a block at a time, it can start sorting them while it's waiting. Now, actual will then show you what the actual execution time was. And now this is in milliseconds. It is not relative to everything else. It is actually absolute milliseconds. Down to the microsecond, which is our resolution on this. If you are doing this on a Windows server, the resolution is lower than that. Windows Server doesn't give us microsecond resolution. I don't remember exactly what it is. The and how many rows it actually retrieved. When this actual is radically different from the expected, that's one of your signs of a problem. One of the other things here to look for is loops. That loop figure is a multiplier. So 7 rows with 1,200 loops actually means roughly 10,000 rows total. It'll give you some conditions, which are generally things that you pass through your own query or are there because of joins with another table. And those are sort of our parts. And then you can have a bunch of other stuff like buffer usage, etc., depending on the options that you're doing. Now, one of the things we're going to have is a lot of operations, which are also known as node types. These are different things that the query executor can do. I'm not going to go through all of these in detail during this presentation because we have to finish up. Look at the slides, which are public, and I'll post in the comments as well. There's a bunch of kind of scans are, let's get data from an index or a table. And Postgres has a bunch of different kinds of scans. MySQL and SQLite have fewer different kinds of operations they can do, but same general principles. So here's an example, a bitmap heap scan, which is a special kind of where you scan the table, construct a bitmap in memory, generally for joining it against another table. Example, joins. Speaking of joins, we have a variety of ways to join two tables together. Postgres picks the different kinds of joins based on what it thinks will execute the fastest. There are a bunch of these. I actually wrote this series for Postgres 11. It's Postgres 13 now. I imagine there's probably another kind of join by now. But there's a bunch of different kinds of joins. Examples of actually a hash join or merge join. The most common ones you're going to see are nest loops and hash joins. They get used more often than anything else. Then there's aggregates, and this is for aggregating data generally as a last step in a query. And Postgres had different ways to execute aggregates in an effort to maximize speed and minimize memory usage. So here's a hash aggregate or a group aggregate. And then there's a bunch of other operations like making data unique, doing a sort, limit for limit offset that can happen in your steps. And then there's a bunch of other miscellaneous operations. And this is actually kind of pretty much just a Postgres thing because Postgres has all of this complex stuff in its query executor. So things like a CTE scan. So I don't know if you've handwritten any queries. Some of those queries may use what's called a with clause, which is a more readable way to do a subquery. And so that will bring the CTE scan node, and there's subquery scans and materialize and append. Materialize is one to look for because it often uses a lot of memory. And again, with a slow query, that's one of those things you're actually looking for. So CTE scan example. So all this comes down to, hey, let's figure out why is my query slow? Well, so I'm going to give you a few examples here. And again, those graphical tools I showed you, and I'll show you again, will give you hints as to which individual steps might have a problem. But I'm going to show you this right here. So this is an example. One of the most common reasons for your query to be slow is that you do not have an appropriate index for the query you are actually running. So like here, for example, we have a query against a table that has 200,000 rows. And we're not using an index. This term in Postgres, sexscan, is another one to look for. Sexscan is Postgres speak for full table scan. And again, not something you want to be doing against a large table. Against a small table, full table scans are great. Against 200,000 rows, not so great. And you can see here, right, is that we're filtering, we're removing it. And so what this says is, I probably need a different index than what I have there. Either an index and category, and whatever it is I'm joining against in the rest of the query, in order for this to be some kind of index scan. Another example here that you'll see all the time is bad row estimates. And this is where those graphical tools can really help you. So here you see that Postgres thought that this index scan was going to return 100 rows, where it actually returned 10,000 rows. So that's 2 orders of magnitude off. And why this is a problem, like if this was the last step in your query, it actually probably wouldn't be a problem. But if Postgres is then joining this against another table, it could be a real problem because it'll use the wrong kind of join based on being 2 orders of magnitude off. There's a fair fuzz factor in this. If it's like off by double, you don't really care. But if it's off by an order of magnitude, you do care. And again, those graphical tools will give you hints as to when you've gotten a bad row estimate. Another thing you actually want to look for is time-consuming loops. These can often be invisible because each individual loop does not take very long, but you really want to look for times when Postgres is looping thousands of times, because again, that's a multiplier, right? This is only 0.03 milliseconds, but it's 0.03 milliseconds 10,000 times, which adds up to a significant amount of time. And in a lot of cases, this means messing with indexes to encourage Postgres to use a different kind of join that would not produce that loop effect. Or if you've handwritten a query, taking out a subquery, turning a subquery into a join, other simple things. So basically, now one of the things that you can do in Postgres is you can start a transaction. You can run explain. There's a whole bunch of query parameters that you can change in your terminal, in a PSQL terminal, that will not affect how the server is running for everyone else. And so you can change those, and then you can run explain again. And that's particularly a good thing to do if you're thinking about changing Postgres settings on the server for everyone, like random page cost is a common one that you will see on Stack Overflow that people like to mess with. Well, you can do that in an individual session and see if that's going to change the query plan in a way that you like. I want to say. So now to finish up here, like I said, I do encourage you to use the graphical tools. They will make life easier for you. Here's explain depth says again. Here's PEV again. There are some other tools. These are desktop tools: PG Admin, PG Analyze. And If you're willing to use IRC, the folks on the Postgres channel on Freenode get bad queries all the time and will help you troubleshoot them if you are patient. So I don't know how much time we have for any questions. I think I actually ran to the end of my time there, but I'm happy to take questions in chat while the other speakers are presenting. Stop sharing.
Thank you for the insightful talk, Josh. I already have one quick question. We'll see. We have a couple of moments for questions from the audience. So if you have some questions, feel free to ask them in the comments. One of the questions that came up is, I know that you stressed the fact that cost was an arbitrary and a relative measurement. I was wondering, what are the two numbers? What is the sort of the meaning of the two numbers that have the two dots between them?
Very important. Thank you. Sorry, I meant to mention that. The first number is the expected cost of retrieving outputting the first row. So remember, every node outputs a row set, right? So that first number is the expected cost of outputting the first row. And the second number is the expected cost of outputting the last row. So sometimes those two numbers will be identical, particularly if you're only outputting one row. Mm-hmm. Sometimes they will be different for that reason. And that's actually super important if you are doing a query with a limit, because Postgres will actually give you the cost. Like it might say 1 to 10,000 is the cost, but if you're doing a limit 100 on your results, it won't actually get to the 10,000.
I see. I see. And that will also happen already at the execution. So this is not something that can be determined at query planning time.
Yeah, well, I mean, you can look and see that there's a limit node in there, right? Mm. But to see what it actually did, yeah, you'll have to try and explain, analyze. Should I answer Dimitri's question?
Yeah, that'd be great.
Okay, so Dimitri's asking, in the course of development, what's the best practice in terms of when to do this sort of analysis? Any opportunities for automated checks? So, in general, for most people, most applications, 99% of your queries will be fine. 99% of your database requests will execute within your SLO and will not be an issue. So, given that, most of the time, you actually want to wait for a problem. You want to do this as problem troubleshooting analysis, right? As in, you have a slow request in in your application, and you've traced it down to a database call, right? So that is sort of the normal way. Now, that said, some people have applications that have super tight SLOs, or that are expected to scale to millions of users, under which every single millisecond is important. And for those sorts of applications, you might actually want to do a general audit. And if you're going to do that, you probably want to have a database expert on staff or as a consultant to help you with that. And there's a couple of different ways to do a general audit, just to answer your automated portion of the question. One is to turn on the logging options. Like I said, Postgres has a ton of logging options. MySQL has a ton of logging options where you can have it log all queries, which I actually recommend, because sometimes what's being slow about a database request is not that the individual query is slow, but that you're doing it 1,000 times. You can log only slow queries. You can log a bunch of details of the queries. You can log memory usage. You can log a whole bunch of other things. So basically, you can output this performance audit log in either Postgres or MySQL, and then run it through a variety of tools that are available to help you analyze that log. PG Analyzer is one for Postgres. There are a couple of others, and therefore see how optimized your application is. And it's particularly, when it's actually particularly useful is if you're anticipating growth, right? So if you see that a particular query against your users table is being a little slower than you'd like it, and you know that you're expecting your users table within the next 6 months to be 1,000 times the size it is now, then you probably need to do some index optimization now rather than waiting for it to break down. The second thing you can do in Postgres, and I don't know if there's an equivalent in other databases for this, is there's a tool called Auto Explain, where you can trigger it outputting the explain plan if it meets certain conditions. And you do that in the Postgres settings. At least through Postgres version 11 or 12, though, auto explain had to be set up at restart time for the database, and it produces a lot of output. So it's a little awkward as an audit tool. I don't know whether or not that particular issue has been fixed to allow you to dynamically turn auto explain on and off without requiring a server restart, which is would make it a lot more useful from that perspective. Because the problem with all of this auditing is it really produces enormous amounts of output. Like in a busy database, I've seen full query logging produce, 50 gigabytes an hour of log output. And you obviously don't want to have that on all the time.
Great. We have no more questions coming from the audience. I think one final question that I think would be interesting to finish the talk with would be, generally speaking, besides slow queries that can happen due to execution, lack of index, and one of the many reasons that you mentioned, what are some of the common reasons for slow queries besides the ones that you've mentioned?
Yeah, so, right, I would say top 3 reasons for slow queries. Like I said, so I mentioned not having an index, right, which is really top. Right, second one is Postgres is, and I didn't go into detail in this, but Postgres is stats being bad, essentially. So Postgres asynchronously samples the database in order to maintain statistics about what's in the database, how big certain tables are, how the rows in those tables are organized, etc. If those statistics are sufficiently wrong, they are always approximate, but if they're sufficiently wrong, it can cause Postgres to take a really bad query plan. Like, for example, if you just bulk loaded 1 million rows into a table that used to have no rows in it, the queries that you run immediately after that bulk load may have really bad query plans. There's a variety of ways to solve this. So you can increase Postgres' sampling rate. I recommend if you do a bulk load call analyze on the database, the analyze command on the database immediately after the bulk load in order to minimize your sort of window of having bad stats. And then sometimes the bad stats are just a result of the limitations in Postgres statistical models. If you look at the 1 hour version of this presentation that I do, towards the end, I talk about one of Postgres' classic problems, which is something called abort early plans, which is a stats problem. And that's actually an example of something that you kind of just have to work around by munging the query. Because it's a shortcut that Postgres takes that can speed up your query by like 10,000%. But when Postgres is wrong, it slows it down by 10,000%. And then the last one is insufficient resources on the database server.
Right.
If you need to sort 1 million rows and you have no memory available in the database server, Postgres is going to sort those on disk, which is significantly slower than sorting them in memory. If you're seeing a lot of that, and this is where that buffers option comes in with explain, if you're seeing a lot of missed buffers, then one of the things that you can do is take your database instance, increase its physical memory. Postgres also has memory limit settings for individual queries, etc. And that's the second thing you can do is is increasing those memory limits. The most influential one for queries is called workmem. And workmem is just a limit. It's a resource limit on the total amount of memory that a query is allowed to take per operation. And it's to prevent too many concurrent queries from running the server out of memory is the reason why that limit exists. But if you're doing a lot of big data analytics type queries, data mining type queries, it's pretty easy to need more work memory than that, than the default. And the question is a 1 hour talk, this one entitled Explain from 2015? I did this in 2015 and again in 2016, I think. And yeah, if you found that, that's the correct one, and it'll talk in more detail about some of these steps.
Thank you so much, Josh. That was very insightful, and I look forward to digging further into the slides and trying this out.
Oh, and I'll post as soon as I figure out how can I actually comment? Interesting.
You can either access that via YouTube, or you can drop the link in the private chat, and then I'll share it in the comments.
Okay.
Great. So all the best, Josh.
Thank you.
Okay, we're now coming to the second part of today's meetup. And for this part, we have two very special guests from the Prisma team. We have Alberto and Tom, who are both working on the Migrate team. Welcome.
Hi, Daniel. Hi, everyone.
Hi, everyone.
So how are you feeling after the release yesterday?
Oh,
good question.
A bit exhausted, but actually very happy to finally see this coming through. I don't know about you, Tom?
Yeah, I think everybody who programs for a lot has this experience of releasing a project after a month of work, and it feels good. It feels good.
Great. Well, you have a demo for us. So I'm going to give the stage to you. So now I'll take myself off, and the stage is yours.
Yes, I'm going to start first with a presentation, and then Tom is going to do a short demo. Going to assume you can see my slides. I'm not used to presenting in these streaming sessions. So today we're going to talk about the Prisma Migrate preview. And as you may know, it was released yesterday in preview in 2.13.0. Okay, so briefly about me. My name is Alberto. I'm based out of Spain. I'm a product manager at Prisma. I joined in March this year. And you can find me as Alberto Perdomo on the internet, Twitter, GitHub, and so on. And I work with Tom on the migrations team. So we're Tom, Joel, Matthias, and me. And our team charter is we want to enable developers to initialize and evolve their database schemas during the entire software development lifecycle. And this means that we oversee and work on Prisma Migrate, but also on other tools that are related to the managing your schema, such as introspection with Prisma Introspect, or another tool that we recently released in preview, which is DB Push, Prisma DB Push. Allows you to do the opposite of introspecting your database, which is pushing your schema from Prisma to the database. And today our topics are going to be a quick refresh of database migrations. And then we'll talk about a bit about Prisma Migrate experimental, then Prisma Migrate preview, and then we'll have a short demo for you. And so first, the refresh on database migrations. What are database migrations at all? We all understand it's a way to manage your migrations, to manage your database schema. But what's really important about database migrations is that it refers to managing incremental changes to your database schema in a way that you can version control your database schema at any point in time. And they should provide a reliable, predictable way to execute these migrations in a way that, sorry about that. Okay. They should allow you to execute these steps, these changes in a reliable and predictable way, and so that any changes to the database are encoded in migrations, and they can execute it in the exact same way when needed to reach the desired end state. And this might be different to, let's say, to using other ways to evolve your database, such as when you use this tool that we recently released, DB Push, for example, that makes sure to bring the database to a desired end state, but you have no control or insight about how that end state is going to be reached. It just figures out what needs to be done to get there. And so let's talk briefly then about Prisma Migrate Experimental, the previous version that we had in the product that we replaced yesterday. So how it all came to start was as a team in June. Our team got together and we were tasked with bringing Prisma Migrate to general availability, and we wanted to first understand the state of where we were. And so, okay, it was an experimental state. It had started, it had been conceived in spring of 2019, and it was an evolution on the learnings from Prisma 1. And the design goals were to be a declarative system. That means instead of encoding the changes the way you want to execute them, you would rather encode the desired end state, and Prisma would figure out what needs to be done. To be database agnostic, meaning these migrations can be executed against a number of different databases, and to support team collaboration as a first-class citizen. And the way this workflow worked was you would first start by making changes to your data model. That's in Prisma. That's done by modifying your Prisma schema file. Then you will run a command called Prisma Migrate Save, and what that would do is generate a new migration in the form of a new directory. And in this directory, you would have a JSON file that's persisting the changes to the schema, and a copy of the Prisma syntax of the desired end state of this migration. Then you would apply this migration by running a command Prisma Migrate Up. This would read the migration and deserialize the change set and apply to the database. And then lastly, you would call Prisma Generate to make sure to regenerate your Prisma client API to make sure it's in sync with your updated schema. So since joining Prisma, I had already talked to many users. As a product manager, my main job is to talk to many users and understand their needs and frustrations and what delights them in their product. And besides that, the first thing we wanted to understand as a team was how well Migrate, the experimental version of Migrate, was working for them. So we talked to many people. We talked to developers who were using the experimental version, sometimes even in production. We also talked to other users who were using Prisma, but they were not using Prisma Migrate. And we also talked to developers who were not using Prisma at all to understand what are the qualities that in general developers look at when looking at migration systems. And our goal was to understand what's working well in the current tool, what's not working well, what are the limitations, the bugs, the design issues, what's preventing new users from adopting it, and what are the things that future potential users of Prisma would be looking for in such a tool. And so the things that worked well were that migrations were auto-generated, so there was no need to write migrations manually. People find this tedious, and so that's something that they were happy to outsource to Prisma. It just worked. When it worked great, and it was like magic. It was database agnostic, meaning these migrations worked against a number of different database providers. When I say database providers, I mean probably in the sense of like different DBMS, like Postgres, MySQL, or SQLite. It does not require any database expertise because it's abstracted for you. It reads you. All you do is change your Prisma schema and generates migration files. And then the things that didn't worked so well in Git version or were missing. Well, an important one was that the system was not deterministic. What this means is even though the change sets were encoded in these JSON files, the system would try to determine at runtime what to do with migrations. This means that migrations were unpredictable because depending on the actual state of the database, Prisma Migrate would decide to do one thing or the other. And turns out predictability in migrations is pretty important to most developers. You want to actually understand how a migration is going to be carried out, and also run it in another environment before running it in production to understand how it's going to be carried out and the actual result. And so if they can work in different ways depending on the state of the database, that's pretty bad. The system also could not always infer the intent from the changes. An example of that is if you rename a field, Prisma Migrate cannot determine if your intent is to rename a field or if you're removing a field and you're adding a new one. And based on this limitation, the current Prisma Migrate experimental, what it did was it decided to drop a column and create a new column for you. And if that's not the behavior that you wanted, you had no way to deal with this. There was no way to express, let's say, encode this different strategy in the migration. There's no control over the migration strategy, and there's no escape hatch. So that means if you need to perform your migration in a certain way, or if you want to do something that Prisma Migrate is not aware of or does not support, it's impossible. An example of that would be you want to create database views, stored procedures, or triggers, which is something that the Prisma does not have the notion of. It's impossible with this system. And two other things is the JSON format. The JSON format for the changes, that works great for computers, but not great for humans. It's quite verbose. It's very long. It would be really hard for developers to change the behavior of certain migration, but also it's not even great for reviewing or understanding what's happening in a migration. It's more meant for the migration implementation itself. And the database agnostic aspect turns out to also have disadvantages, so meaning that, as I said before, the set of features that the migration system supports is limited to what can be encoded in the Prisma schema. And that means anything that the Prisma schema language does not support, it's unavailable for migrations. So with everything that we learned, we decided to go back to the drawing board and allow ourselves to question the design decisions that shape the existing Prisma Migrate solution. And so let's now dive into this evolved version of Prisma Migrate, which we released yesterday, as I said before. So how is it better? This new version uses imperative deterministic migrations. The migrations will be predictable, and you can write your migrations in your development environment and understand how they're going to behave in other environments, such as staging or production. We also abandoned the JSON format for schema migrations in favor of SQL or DDL. Using SQL allows developers to have full control and transparency over the schema migrations. And we also removed the magic aspect from such a crucial piece of your application code. And while SQL might not be, say, everybody's preference, maybe some users who are not familiar, for example, it's also worth noting that when you are staying on the happy path using Prisma Migrate, there is no absolute need to write or customize these SQL files. We'll see more about that in a minute in the demo. Migrations are also still auto-generated for you. This is something that people valued in Prisma Migrate, and we wanted to retain that. We think writing up and down migrations manually is a lot of toil work. There's a lot that goes into it, and removing that burden from the developer seems like the right thing to do. When you're doing simple additive schema changes, meaning you're adding fields, you're adding tables. In fact, there's no even need to look into these files at all. But when you need to customize these migrations, meaning you want to orchestrate a migration in a certain way, you need to manipulate data in between changes. You want to change the behavior that Prisma Migrate is going to apply to a certain migration. Let's say you don't want it to drop a column and create a new one. Instead, you want to actually alter a column to rename it. You can do that. And you can also do that if you need to extend migrations to do things that are not yet supported by Prisma. So if you can modify those SQL migrations, and you can create sort procedures, triggers, and database views, and all of that. The workflow is fairly similar to what we had before. Now we've unified in development, we've unified this into one single flow and command. So it all starts again with making changes to your Prisma schema. And the next step is for you to call a command, Prisma Migrate Def. What this does is it picks up changes to your Prisma schema, generates a new migration. This migration file, this migration has a SQL file with the migration script. It also updates the database schema by applying that migration, and it also triggers the generation for you. The reason we decided to include the generation into the tool is because we heard from users that often they would migrate the database and then forget to trigger the client generation, and they would get runtime errors because there was the client was not in sync with the schema. So it just made sense to update the client whenever updating the schema in development. And so once you're done, all you need to do is you commit the Prisma schema and your migration file to your repository. And from there, your colleagues and team members can check out these new migrations, run the same command, and they will figure out which migrations need to be applied, apply them, and so on. And we've also got a workflow that's aimed at deploying migrations. And we've heard from many people that they have automated CI or deployment pipelines. They were a bit frustrated as well because the previous Prisma Migrate was interactive. So often they had to somehow make sure they're providing certain options. They're passing certain options to the command to avoid the pipeline getting stuck in an interactive mode. But also by doing that, it means you're not there to make a decision when the tool is asking for it. And so what we wanted to do is to front load all of the decision making into the actual migration step. That means, like, if you by committing the file, you should understand what changes are being committed and how the migration will be carried out. If you want to understand how that works, you can look into the SQL file and understand, even if that's not the SQL that you would write, or if you don't have the level of knowledge that it's required to write the SQL, you can probably understand it, because understanding DDL is pretty reasonable. But once you commit this change to the repository, and all you want is to deploy these migrations, you don't want to be making decisions during deployment time, which is why we have this dedicated command called Prisma Migrate Deploy. And all it does is it checks based on the local migration files, that you have previously checked out in your CI deployment pipeline, for instance, or locally. You will check for which migrations are missing on the database and apply those. And we've got, there's few more details about the tool. There's few more capabilities that there are in for production deployments. We have a status tool that helps you understand what's happening with the database and the migrations. We also have a resolve command that helps you fix these issues. And the Migrate dev also helps you get back on track when you step off the beaten path. But that's probably too much detail for today's presentation. So maybe it makes sense now to move on to the demo, and maybe Tom can do a live demo, and we hope to not upset the demo gods.
Yes, it's always a risk. So yeah, I'm going to show you a little bit how it feels, how it looks like in practice in a project where you're using Prisma for the database, and a few things you can do with the tool. So I'm going to share my screen. I need a second. So an application window. Okay, this one. Can you see my editor? Yes. Good. So I'll be quick because a bit over time. But imagine you're on a fresh Prisma project. You have your schema that's empty. You have database you're connected to, but it's also empty. And you want to start coding a block style application, let's say. So you start as usual. You're going to add a few models. Yes. And where I'm diverging from the workflow we're imagining is that you need to start using Migrate. You can, of course, use Migrate from the start of your project. But maybe at the beginning, when the project is still in a very fluid state, you want to use DB push. So you just change your schema, use DB push. Your database schema is going to reflect your Prisma schema, and you don't have to worry about migrations. But at some point, you're going to want migrations, and it doesn't have to start from the beginning with migrations. Yeah, so we are going to have a user model for applications. We're going to have a post model for something like a blog post. So also there, and there's a relation between the two. So posts have titles, I imagine. And then there's a author.
Hey, Tom, could you please make it a bit bigger for us?
Bigger, yes. Is it better?
One more would be great. Fantastic.
Okay. Yeah. So here we are with our first models. And now we want to generate a migration to actually make these models appear as tables in our database. So I'm using Postgres for this demo. And the command we're going to use is Prisma Migrate dev for development. You need to pass the preview feature flag. And it's going to do two things. So, yes, it's going to ask for a name. Initial migration. Let's give it a simple name. So it says it generated the migration, it says it's generated the Prisma client, and that everything is now in sync. And if you look at the migrations folder, it did generate a SQL script where it created a table for users, created a table for posts, and then did a bunch of things that you don't need to worry about that. And that's already applied to the database. Your client, Prisma client, is already generated, and you can already use it. So I took a slight shortcut, and I already wrote seed script, which is something you would want for that kind of applications, because in a lot of cases, it's easier to just wipe the database, start from scratch, and have a seed script that's going to put seed data in the database that you can use for testing and development. So I already wrote the script, but you can see it's just a basic TypeScript file, imports the Prisma client, and puts data in the database. So it's going to create one user, create a second user, and create a post and associate it with the first user. So I'm going to run that script just to check that it works. Okay, we created two users. we can go on. Now I want to add a third model. So I'm going to add tags to the posts. So let's has an ID that has tags have titles as well, I imagine, and so a tag is associated to many posts, and a post may have many tags. So it's a many-to-many relationship between the two models. But here I don't want tags that contain a whole, like the Prisma schema isn't super precise here on what we are intending to put in the database. So if you have the post contents, for example, it's a string that can be very long. If you have a tag, like you expect the title to be pretty short. So we can encode that in the database in Postgres case. You could have check constraints and all sorts of things, but we just want to change the type of the title column. You'll see what I mean in a second. So I'm going to run Prisma Migrate dev again, but pass the create only flag. And what this does is it does exactly the same thing as migrate dev, except it's going to not apply the migration. So it's going to generate the migration and stop there. You can use that when you want to edit the migration before you apply it to your development database. So you generated a second migration, and the second migration created the many-to-many relation you see here and the tag column. And what we wanted to do is the tag table. Sorry, we wanted to limit these the tag titles to 1,000 characters, 100 characters. So you can change the types of generated columns in the migrations because we are going to run exactly that. And any SQL you put there is going to be run exactly like that. So you can customize things. So we are going to run dev. It's going to apply that, and then we have that in our tags in our database. But maybe it's ambiguous to have posts with titles and tags with titles. So we decide in the end, maybe I want to call that column name instead. So with migrate until yesterday, it would drop the title column, create a name column. And in this case, it wouldn't even work if you have data because it drops a required column and it creates a new required one. And yeah, it's causing a lot of complications. What you want is just rename that column. And until yesterday, there wasn't a way to do that. We might make it more high level, but at least now we have the escape hatches to at least allow that. So rename tag title. So since you can change the SQL, you can see that migrate would drop the title column and add a name column and lose the data in the process. What you can do instead is just edit the migration, rename column title to name. And now you can run that. So that shows how you can edit the migrations. Let's see another case where you would want to edit the migration. It's when you want to do data migrations. That's also something we didn't support in the previous migrate. So imagine our users have a first name and a last name. We are going to make that happen in the database. Yes. So we are in a case where we have data already because we seeded. And we are adding required fields. So there's nothing to put in these fields, and we can't put null because they are required, so that migration can't be executed. So that's one case where you would use Prisma migrate reset. Yes. We are fine with losing data because we have a seed script. We can run it again. In general, it's good practice in development. Oh, what do I have here? Oh, that's interesting. So my seed script, since the Prisma client is regenerated all the time, my seed script doesn't type check anymore. So let's see. Yes, we have 2 new required fields here. So we have first name, last name, oh, that's me, and Tim. Okay. And we're going to run that script, and now that works. Oh, the current name does not exist in the current database. That's the magic of demos. We run the migration. Ah, yes, we didn't run that. So we have that migration that adds these 2 columns to the database now, and it's been applied. So now we can run the script. Yes, good. So what I wanted to show is, imagine you realize in your application that first name, last name doesn't fit. Like some people only have a last name, some people have middle names that they care about, and you just want to simplify things and have a single name column. But you still want to not lose your data, right? So what you're going to do is what we call what's called an expanded contract pattern, where you first, so you want to move from schema A to schema B. You're first going to add the things that you want in schema A, then migrate your data you want in schema B. So we're adding the new field. It's going to be empty. Then you move your data, and then you clean up after that. You remove the old tables. And depending on your data volume, and if you have migrations that run over huge tables that may take hours, and you want to do it without downtime, you can split that to be very fine-grained and write to the old fields and the new fields, and then do the data migration separately and all that. But we are on a very small scale. It's a very new app. So we are going to do that in a single migration. Is the last step I wanted to show. So we are going to add that name step. Add migrate name. We have that name step. And what we're going to do is so after that step has run, we would have both the old and the new values in the table. So we would update user, set name, and we are going to just concatenate first name colon and the last name colon. I hope I didn't make any syntax mistake. And here I edited the migration. So it's already applied, but I edited it. And the dev command is very strict about making sure your database reflects the migration files. So it's going to ask me to, whoop. Ah, yes, syntax error. Update. Was it update from? Oh my, I'm tired. No. Let's see. What did I get wrong? Anybody has an idea on the chat? Yeah, so you see the downside of this approach right now is that we are still using SQL, and if you're not used to using SQL, let me check. Oh, that's very embarrassing. Let's see. Okay, I don't get what I did wrong, but I saw Hervé's comment. Oh yes, okay, so I fixed it, and okay, so that was right. I don't know what was wrong before, but so you can update the data, do any kind of data migrations, Right now, it has to be SQL. We're looking to see, okay, is it going to stay that way or not? We are taking all kinds of feedback, and we are interested in everybody's feedback. But yeah, and so Migrate is very strict about sticking your database schema with the migration files in development. So it's going to ask me to reset the database, which is why it's nice to have a seed script. But here we have that migration that does that change and then copies the data. And then we are free to remove the old fields in the next migration. Clean up things. So that's all I wanted to show, more or less, for today. And I hope it gives you a good feel of how it works. I don't know if we have time for questions.
Thank you, Tom. That was great. So we saw quite a few of the workflows that are supported. And we had a question that was already answered, but perhaps you want to chime in on how to approach essentially migrations in multiple environments.
Yes. Yeah, so I already replied in chat, but the workflow, so it's a tool that's kind of baked in to a workflow where you have dev in development. And basically you're working with a development database that's disposable. In a lot of cases, it's going to ask you to reset the database and reapply the migrations from scratch. So you don't have to maintain down migrations. And it's going to tell you exactly when you need to do it and do it for you. But that means also you have to not care too much about your development data. That's why you should have a seed script that can be, like me, like I showed you, a Prisma client, TypeScript script, perfectly normal, that just puts data in the database. Can be a SQL script, can be an import from a CSV, can be anything. So you have this development flow where you basically are going to reset all the time. And then when you're ready, you merge your, so you commit your migrations, you get that hopefully code reviewed, and then you merge them to your main branch where you can do that manually at the beginning, but usually you'll do that through CI. Once your code changes are merged, there's maybe a manual step, or maybe it happens automatically, but your code is going to get deployed. And at that point, you use Prisma Migrate deploy that will run the migrations as they are saved in your migrations folder.
Great. So on this note, I'd like to wrap up this talk and thank you once again for the demo and thank Alberto. Do you want to mention a couple of words on what's coming up for Prisma Migrate?
Yeah. So one big limitation we have right now with Migrate is that we have this new feature that's touching the whole of Prisma that's already supported in client and introspection. That's native types. And that's not supported in the new Migrate yet. And of course, we want to support that all across Prisma. So expect to see that. It's hard. It's a big feature, but we'll work on it. It's a priority, and expect to see that in the not too distant future.
Yes, I'll bring Alberto also. Alberto, welcome.
Hey, so yes, besides native types, as Tom said, a few other things that we're looking into. One of them is seeding. So seeding has been a long-standing request for quite some time. And as you may have seen, it's quite critical as well, especially in a context where we're resetting the development database very often. So we're very likely to look into that in the near future. And then some of the other topics that we may look into are rollbacks or down migrations. Some people have expressed that they would prefer to have down migrations. We think that's a burden for most of the users, but we recognize some people want it. So we're either looking into some kind of down migrations that are opt-in or some other mechanism to roll back migrations. And the other topic is DSL for when you need, especially for dealing with data manipulation. As you may have seen, it might not be as straightforward for everyone to write SQL, and we're aware of that. So this is something that we would hope to streamline in some way.
I see. And with regards to the native types, basically the idea would be, right, that users would be able to similar to how Tom had to modify the type from text to varchar. With native types, you'd be able to do that directly from your Prisma schema by annotating the field. Is that the sort of intended goal?
Yeah, there's two sides to native types. One is there's a feature called native types that's currently in preview, and once Migrate supports that feature, which hopefully soon, what it means is you can use these custom types in your Prisma schema, and Prisma Migrate will pick the right column type for you and make all of that seamless, so it's transparent. You don't need to actually go into the migration and edit it. However, there may still be types that that you may want to use, which are still not supported by Prisma. An example of that would be maybe you're using PostgreSQL and you want to use geometry columns, and we still want to enable developers to use these kind of types, even if they're not supported in Prisma schema. And for that, we also need to do changes, not only to Prisma Migrate, but as well to the Prisma schema to allow some kind of column types to be ignored, or columns to be ignored by Prisma.
I see. Great. So on that note, let's wrap up. Thank you once again, Alberto and Tom.
Thanks everyone.
Thank you.
Okay, and now we have our final speaker for tonight, and that is Dillon. So,
Hello.
welcome, Dillon.
Hey, can you hear me?
Yes, I can hear you. So, you're going to present a marketplace app that you've built with Blitz.js and Prisma. And you're going to showcase how easy it was for you to work with relations. I'm going to give a little introduction. So you are actually the founder of a product studio called Creators Never Die, and you're working and experimenting with your own products, but also cooperating with a wide range of clients, ranging from rapper Waka Flocka, which I really want to know more about, and fitness studios. And you're joining us from Canada, if I'm correct.
From Toronto, Ontario. Yeah.
So welcome.
Thank you for having me.
Cool. So are you ready to share your screen?
Yes, let me do that now. Maybe what I'll do is I'll go through my slides first, and then I'll demo the marketplace afterwards to show exactly how it works. So let me do that now. Maybe what I'll do is this. Okay. So you able to you can see my screen?
Yep.
Perfect. Okay, so this talk is about mostly how I work with Prisma now for client projects. So little introduction about me. I'm a BFG, which stands for Big Freaking Geek. I'm also the founders of Creators Never Die, which, as you said, is a product studio that I founded a few years ago, working on my own products and also clients' products. We got approached to create a marketplace, which was a great concept to get our feet wet with Blitz.js and Prisma. As I've been watching them closely, I was trying to find a good project to start working with. Coming from a Rails background, the mix of the two really felt like home. The speed of development was insane compared to manually setting up migrations and different ORMs with Express.js. It got pretty tedious doing the same task over and over again, which is why I felt like the Blitz and Prisma stack was great to work with. Funny enough, as this is a migrations talk, my favorite Prisma features so far definitely are the CRUD queries, setting up the models in the schema, and hence the relations, and the migrations, which made it really easy to collaborate with the team and making sure everyone's database is up to par. Creating a product in the marketplace required the following models, which was the storefronts. So many users could open up their own storefront and start selling products on their own storefront. The products themselves and variants, the variant children, and variant inventory. So the variants itself were kind of like a container variant. So in this case, if you want to think of selling t-shirts, for example, there could be colors, different color t-shirts, different sizes, or if you're selling laptops, for example, different memory speed, etc. The children itself would be related to the variants. So in that case, so if we're selling t-shirts, the colors would have different colors. So a red t-shirt or a green t-shirt, for example, or different sizes, small, medium, large. And then actually keeping track of inventory, which was associated to the variant children. So as you can see, there was a huge nest of relations, and dealing with forms is usually pretty complicated, but actually we had a pretty good time doing it with Blitz and Prisma. So as I said, working with relations in Prisma was a breeze, especially when dealing with nested forms. We ended up using on the front end React Final Form, along with the mutator that they supply called React Final Form Arrays. Let me know if you're able to see the code. I'm not sure, but this is kind of a redacted code showing how to set up the array mutator for the outside form components. So you could see it's just a matter of adding the array mutators to the actual mutator, and then having our variant field components, which I will get into now. This might be a little too small. If it is, when I actually demo the marketplace, I'll actually go through the code on my screen. Are you able to see this, or is it too small?
It's a bit too small, yeah.
Too small? Okay, so I'll get back to that when I go through the actual code in Marketplace. Prisma made it really easy to create and query products. I was able to traverse down through all relations by using the include syntax, which was great for allowing us to showcase the variants and prices associated to them, which I will also go through. Although one issue we did come across was adapting the data to work with the nested forms. So we ended up hacking together what we call an adapter that checks which Prisma write options to use. So for example, knowing when to use create versus connect or delete, etc., got pretty complicated when working with arrays within arrays within arrays. So sending back the data as is won't work, because we want to create actual entries in the database for the variant and the associated variant children and inventory. So the adapter sends back the data adapted to the structure Prisma is expecting. Again, I don't know if you could see the code. I hope you can, but the data without the adapter would just send back a simple JSON with, like I said, arrays within arrays. But then when we wrote the adapter, this is how the data ended up coming back, which was perfect. How the adapter works, we ended up creating a get diff function, which, if you don't know, it's just finding the difference between the initial array of data, if there is, and the actual values being sent back. So that calculated the two objects. The diff function had 4 params, which is the value, the current data being sent from the form, the initial data, and then the mapper function, so when we needed to access the array within the array, for example, and then a force connect, which if we wanted to have like actual definitive control when to use connect versus update, we could just set a Boolean of actually using connect. So the get diff function itself contained 3 filter variables, which would be the create, update, and remove. So what that did is each filter through the supplied data from the actual value params and will actually determine what to use, whether it's create, update, or remove. This is the code itself. Again, might be too small, and if anyone really wants to see the code, I have no problem sharing it, and as it could be quite useful for future projects. So maybe I'll send it in the comments, or you could hit me up on Twitter, and I'd be happy to help. So this is, as you can see, the create variable, the update variable, the remove variable, which are just simple filter functions. And then we return the object. So whether there is, let's say, for example, data that is in the newly created create array from above that variable, then we use the actual create write option, or else it comes back as undefined. And the same for update / connect or delete. Then we export the product adapter function that accepts the values and initial value params. So this is the actual function that's being used inside of your onSubmit with the form. So the product adapter just returns all the data while using the previous getDiff function for arrays. So in this code here, so as you can see, the product has variants. So if there are variants, for example, use the getDiff function to sift through all the data and use the correct write option. So as you can see, inside of the onSubmit, or in this case with Blitz.js, if you're not familiar, Blitz.js offers mutations for writing data and then queries for querying data. So you could really use it in either the onSubmit or inside of the actual mutation, which you can see here, we're just sending the data as a param inside of the product adapter. But it seems Prisma is already working on something similar, allowing us just to supply a foreign key directly, which is pretty useful. But I'm not positive. I think this is only working with Connect. Either way, this I feel a pretty good feature. And then, yeah, so we're finally at a point in the JavaScript ecosystem where things are just starting to work, and that gets me excited, as we like to work with one syntax, one language. I plan on using Blitz and Prisma for most projects here on out, so that's pretty cool. And also, if anyone's looking for contract work, feel free to hit me up on Twitter. And that's that. So what I'll do now is maybe go through my actual marketplace. So let's see, let me share my full screen. Okay. So let me just start it up. All right. Perfect. Give it a sec. There we are. So just making sure I'm logged in. I already got things set up, and for time purposes, I created a test storefront with the actual product itself. And just to show you how that is nice to query, for example, if we quick view this product, as I was talking about here, the variants. So the variant parent being the color, and then variant children being green, and then the inventory counter, for example. And it's just simple to add to cart. But what I'll actually go through is showcasing the nested forms and creating the product itself. So I'm just going to go to the storefront settings here. I'm going to go into products and then add a product. Yeah, it's still a little work in progress, as we've been focusing on actually handling shipping, so printing shipping labels. That's been our main focus right now. So it's still a little front end is still getting there. So let's create a test product 2. As you can see, I've done this a bit. Anyways, we will just select the category. For now, we only are using uncategorized. We'll upload some images. So in this case here, we are able to choose between whether the product itself is actual physical product or a digital product. If it's physical, we'll just enter in how big the actual product is for shipping purposes when we actually create the shipping label for you. We'll just enter in random info. So this is now when we get into the nested forms. So I'll just press here, and so now this is the actual variant parent. So in this case, again, I'll stick with color just for simplicity. And then I will create another nested array that's associated with that variant, like so, which gives me a different form. So in this case, we could say this is the color red. Let's say $100, just a random SKU number. You could put a sale price if we want to put the item on sale, and then another upload form for that. And now we are able to actually add the inventory for that. So as you can see for the model above, we're going to choose the red variant, and we'll just say there's 100 of them in stock. And so if we submit, it'll create the product and then take us back to the page where, again, we see the variants and would be able to select different variants, and it would update the price on the fly. I guess I could also show the checkout process, or maybe I'll go through the actual adapter code itself, so to show you how that all works. So here is the adapter. I'll zoom in. Is that good? I'm assuming so. So as I was saying, here's the getDiff function, where it's accepting the value params, the initial data. We'll have the mapper param, and then whether we're using force connect. And then we'll have each variable, which will loop through the values from the form that's being submitted. Or in this case, we'll filter if there's no item in the array, then we'll end up adding that to the create array, or update and remove. And then this is where I guess you could say the magic happens. So if there's anything in the create variable above, then run through it and use the create write method. Otherwise, it's undefined. Here is where we update, or in this case, if we're using force connect, where if there is already a item in the database, use a connect write method. And here we're just running through to see, for example, if there's children associated with that array, and to see actually which values are updated and which aren't. So that is a little bit of a hack, and we're working on cleaning that up. But and then the delete. And so as you can see, we just return the actual object with the rest of the values. But in this case, for the variance or the quantity / inventory, we're using the getDiff function. And yeah, that's pretty much it. Be happy to answer questions also if anyone has. I don't know if I went too fast or too slow.
Thank you, Dillon. That was quite interesting to see. So you've built this with Blitz, and I think one of the first questions that I was curious about. So Blitz is a React-based framework that integrates Prisma, and the whole idea behind it is that you don't have to sort of define this API layer, right? You expose these functions essentially from your backend, and you can call them from your front end. And one of the things that I was curious about when sort of looking through your presentation, which was really insightful, does the getDiff function actually run on the front end or on the back end of this?
That's being run on the back end. That's being run on the server. And yeah, so that's the great thing with Blitz, really, because we started off using Next.js, which is what Blitz is built on top of, and then we would have to write, let's say, an API with whether it's Express or Rails, and then sometimes, of course, there's times where you want to have microservices and have the backend on its own separate server, and on the front end on a separate server. But traditionally, I think the whole monolithic framework approach really makes it easier to work with a team and developers and just get the bigger picture of the product. And so Blitz does a very good job at that. So separating the actual backend code when it needs to, and then the front end code with Next. So really, so yeah, that get diff, for example, is being run on the back end, whether it's in the mutation, like I said, or the on submit. So yeah, technically it could be run on both ends. In this case, it's on the back end for us.
Cool. We'll see if there's any questions coming out. If you have any questions, this is the moment to ask them. And if not, I'd like to thank you again, Dillon, for showing a bit of how you work with Prisma and Blitz.js. And I hope to see you soon. And
for sure. Thanks for having me.
Pleasure. Okay. So we now come to the end of today's meetup. And I'd like to thank you all for joining us, and thank all the speakers, Josh, Tom, Alberto, and Dillon. Really insightful talks. If you haven't already and you're watching this on YouTube, be sure to click the subscribe button. That way you can be notified about all of our upcoming meetups. We also have next week the What's New in Prisma live stream, so stay tuned for that. And on that note, I'll wrap up. So thank you.